going to learn more about the idea of what coordinates really are and what they mean, as well as something called the change of basis matrix. So we're going to start with the idea of we have this vector 3 comma 5, and I want to just say, what does that even mean when we write 3 comma 5? Well, generally people learn that 3 comma 5 means that you're going to go 3 in the x direction, 5 in the y direction, and that's going to be your vector 3, 5. And that's just by convention. We just agreed that that 3 meant go right 3, and that 5 meant up 5. If you came from a different world, maybe you were not going to call it that way. Maybe 3, 5 means you would go up 3 and right 5. I mean, there's nothing inherently that has to be done with the first number being left, right, and the second number up, down. It doesn't really matter. And we can even get crazier than that. Let's suppose I have a basis here, 1, 1, 1, negative 1, and then I write the vector 3, 5. Now I'm going to put a little b in the lowercase here to indicate that this is not our normal 3, 5. This is a new way of thinking about 3, 5. And what I mean by this, is first, you're going to go 3 in the direction of 1, 1. And then after that, you're going to go 5 in the direction 1, negative 1. And so 3, 5, little b here is the same as if you'd went total 8 in the x direction and negative 2 in the y direction. Now what I'm just trying to get at here is that the idea is these numbers here, these are called coordinates. And normally we call them the x coordinate and the y coordinate because they tell you how much to move in the x direction or the y direction. But if we go ahead and have a new basis here, then in some sense this becomes the 1, 1 coordinate instead of the x coordinate, because we're moving that much in the 1, 1 direction instead of the x direction, and this becomes the 1, negative 1 coordinate. And in case you're wondering why would we actually care about something like this, well, very often in physics problems, and this is a very classic one, for example, it's called mass on an inclined plane. The idea is you have some sort of a ramp here, and then you've got a box, and this box has some amount of weight to it, and then your question is how fast is it going to accelerate down the slope? Well, the main force that we normally deal with is gravity on this box, and then there's also going to be a force of friction and maybe some other stuff that's going on in this problem depending on the context. But regardless, we have different things going on here, and the thing is they're not all in the x or y direction. Some are at this angle here, and if you try to solve it using your normal x and y coordinates, you're not going to easily see how fast it's going down there because that's not a direction that's x or y. So it might be more convenient for you to pretend that your axes are x and y here instead of the normal x and y. That's called changing your coordinate system. And as a result, the problem becomes a little bit simpler to do once you've changed your coordinate system. And so that's what we're trying to do in mathematics here. We're trying to learn how do we change our coordinates. Now, I specifically did one vector 3, 5, and we learned about what it would mean in terms of the standard basis, 8 right and 2 down. But what if you wanted to create some sort of method by which you can convert any vector from one basis to another coordinate system in an easy way? And it turns out there's such a way to do this. There's going to be what's called a change of basis matrix, this P matrix here. And if you take that and you multiply it by a vector that's written in terms of B1 coordinates, then the answer is going to be in terms of B2 coordinates. So for example here, I had B is 1, 1, 1, negative 1, and I need to give a name to my standard basis, so I'll call it S here, 1, 0, 0, 1. Then if I found a matrix that went from the basis B to the basis S, and I multiplied it by 3, 5, the answer I'm going to get is 8, negative 2. And the reason why that is because I took a vector that started in basis B, and I got the answer that was in basis S, and I'm claiming there's a way to do this for any input vector. You find one matrix P, and that's going to keep working. Okay, so how are we going to actually find this? Well, there's a process here. It's not very pleasant, I would say. But you take your two bases, you write them in columns, and you join them into one matrix. Then you do row operations. And once you've gotten the identity on the left-hand side, you are going to get the P matrix on the right side. So, for example, if I make my life as easy as possible here, and I go ahead and put my standard basis, this is my S, and then my B basis here, that's what I got in the previous problem there. Well, this is actually already in the format INPB, so that means this is going to be the matrix, so P, B, S. It always kind of goes reverse there, B to S. Sorry, yeah, is going to be exactly 1, 1, 1, negative 1. Okay, so that means if you're currently in base B and you want to get into standard basis, you're going to do this. And it turns out if you wanted to go from standard into the base B, you would actually, sorry, not the inverse there, you would just take the inverse of the one you already had, and that would give you the other direction coordinate change. So for example here, I want to find the change of basis matrices between these two here. So let's go ahead and put the first basis and then the second basis, and we do a bunch of row operations here. Again, I will go ahead and just let my calculator do the work for me. So I'll go ahead and put in all these numbers there. Then I'll go ahead and do my row reduction. And what I'm going to get here is 1, 0, 0, 1, 3, 2, negative 2, negative 1. And so that means the change of basis matrix from B2 to B1 is 3, negative 2, 2, negative 1. And if I wanted to find the change of basis matrix in the other direction, I'm just going to invert that. And let's see, the determinant is going to be 1, so using my shortcut here, I should get that right there. So again, if you want to find the change of basis matrices, all you have to do is just do row operations on this augmented matrix. And if you want to find the change of basis matrix in the other direction, you can just find the inverse of the first one. Or you can do row operations again, it's your choice. But this is how we do it. This is how we find our change of basis matrix. Now, there is one thing that's kind of interesting is we can also talk about coordinate vectors in weird vector spaces like polynomials here. And if we use the basis x squared x1, the standard basis, then if we have a vector that is the polynomial 3x squared minus 5x plus 2, I can write this as this vector 3, negative 5, 2. So in some sense, I'm making it look like a regular R3 vector, but it is actually a vector in the polynomial space. So this whole idea of coordinates is actually a really big topic in physics and engineering, and they do this type of stuff all the time. Also, if you were going to say do some programming and you wanted to include physics in your game or whatever other software you're going to be encoding, you need to be able to do this change of basis problem. Otherwise, you're not going to be able to have good code. So this is an important understanding here, in any type of physical problem.